Number 42. To make gold stronger and harder, it is often alloyed with other metals such as copper and silver. Okay, consider two alloys, one of gold and copper and one of gold and silver, each with the same mole fraction of gold. Okay, so same amount of gold in both. If the gold copper alloy is harder than the gold silver alloy, then which of the following is the best explanation based on the information in the table above? Okay, so yeah, I guess you really need the table, but you really don't need any of these guys or these guys. It really just has to do with something with the metallic radius, and let me explain why. If you guys understand the very point of an alloy, like what's the purpose of it and what it does, I mean, this question is a joke. The most commonly used alloy, I guess, in today's world would be something like carbon steel, right? It's not just normal steel, like it's not just random, like it's not just regular iron. You actually squeeze in all these carbon particles, like in between all those iron molecules or atoms, and you basically make, excuse me, make the steel a lot harder. Now, how does that happen? This is what happens. Imagine you have all these iron, right? So you have an iron, and iron, and so forth, right? I'm just gonna draw 6. Now, take a look. The very reason that, you can actually like bend, a sheet of iron or like break a piece of iron or whatever you want to do with it, well, it's because there are all these little gaps right here. Like, let me just kind of like use a highlighter. So like all these regions are basically kind of like empty regions, right? Like there are these gaps in between. Well, why are there gaps? Because think about it, they're all iron atoms, right? And like irons are all transition metals, well, what we call like sea of electrons. Well, they're not gonna be very, very super tightly bonded to each other because they're all metals, right? Unlike maybe if we were to talk about like a covalent bond between a metal and a non-metal, well, that's a lot stronger. So this has all these rooms, and that's why when you put enough, force on it and like you want to damage it, well, it can bend and it can break. But think of it this way. Imagine I grab some carbon particles and like squeeze it in between all these little iron atoms, like something like that, right? Then now, if you think about it, now we're filling those empty spaces. So what basically, what it basically does in terms of, I guess, chemistry speaking, that actually limits the mobility of the iron atoms within that particular, I'm just going to call it iron sheet, right? So the irons are less mobile to move around. So they are not as flexible to move around in between those freely available spaces because now carbons are all filling up those spaces. So since these iron atoms now have a very hard time moving around, they are more likely to be fixed in position, which is what makes the metal more hard and brittle, right? So that's the concept right here, and that's really just the whole point of an alloy. So going back to this question, the fact that this copper does a better job to create a gold alloy than the silver does, if you guys take a look at the table and compare the metallic radius between the silver and the copper, well, copper's got smaller atomic radius. So what happens is this. You are able to, if I were to kind of explain this using this, so now I'm just going to, instead of an iron, I'm just going to call these gold. And then, well, let me just first show you the case of, let's say, silver, right? So imagine these were silver. They're pretty big like this. So you put the silver in, but because the radius is quite big, you still have, let me color it with different highlighter, you still have these blue regions right here that are still not, being able to be filled because, silver is a little too big to fit in there still, right? So you still have those regions, but imagine instead of silver, now we're using, copper, right? So copper is smaller, so I'm just gonna make it like dramatically smaller just to like give you the idea. So copper, let's say it's like this tiny. Take a look. I mean, alloy is not gonna be this tightly packed. Like you can't fit in that many coppers this tightly, but I'm just, once again, making the picture very extreme for everybody to easily understand. If you can see, the smaller molecules of copper, smaller atoms of copper are actually able to fill in all these empty regions much better than the bigger radius version of the silver atoms. That's why anything that has to do with smaller atomic radius or metallic radius in this case. Well, smaller radius means smaller size particle, and smaller size particle means you can fill more in there. Do you guys have you guys ever heard of that little, this is like some motivational speech or whatever, like if you have a cup, right, you can fill that with rocks, right, like piece of rocks, right, and there are all these like empty spots that will not be filled with rocks. So what else can you do? Now you can pour sand in it, and those sands will take up some of those empty spaces. But still, even then, like there might be still some spaces that are not filled. So you can even pour more water in it. So basically, you're just pouring more and more of these molecules that are smaller and smaller and smaller in size, so you can completely pack it with as much stuff as you can. So that's kind of like the idea with the alloy, right? If you have smaller particles, it's easier to pack it in there. That is why anything to do with the size would be the right answer, which is going to be answer choice C, where it says copper atoms are smaller than silver atoms, thus they interfere more with the displacement of the atoms in the alloy. Long story short, what that is basically saying is it limits the movements of the iron particles, or the gold particles, I'm sorry, in this case, and therefore it's going to make the whole alloy more hard and brittle, like what I just explained before.